Hello, good evening, everybody. And Engineering Mathematics 1. Regular classes will start from 20th April 2015 at 6:30 to 7:30 p.m. on my website bishmathiq.com. And today's session is what we are going to discuss is multiple integrals. In multiple integrals, we are going to discuss about double integrals and triple integrals. Double integrals and some problems and triple integrals. And what do you mean by double integral? The double integral, the presentation is given by, this is our website quotation: teacher, online virtual classroom, whiteboard, live chat box, session recordings, online test, PPTs, materials, quiz questions, and many more features all in one account. Sign up and enroll. Connected to the right mass tuitions. Next, let me add new goal to discuss our topic: multiple integrals. Okay. So here I am choosing the green color board. For that I am choosing the white color pen. Okay. The topic name is called multiple integrals. Multiple integrals. Let me just have one chance. Pass it. 1 minute. Okay. Multiple integrals. And basically we know how to evaluate the integration. Is it improper integration or definite integrals or indefinite integrals? Generally the integrations of single variables, integration of function of single variables are denoted by like integration of f of x into dx, and here the function is whatever it is the function. It may be algebraic function or a trigonometric function or logarithmic function or multiple product of multiple functions. And there are some basic formulas are there to evaluate this type of integrations. If your integrations, you will get one more function. That function is called as capital F of x, and finally after integration we should add some suitable constant c. This is a basic integration, already we know. But today our topic is multiple integrals. The multiple integrals are the integrals which are having, we are going to evaluating by using successive multiple integrals. For example, the general form of the multiple integrals are, they are called either double integrals or triple integrals. Double integrals, double integrals or triple integrals. Generally we will discuss about these two type of integrals, because there are so many applications are there for engineering level about the double integrals and triple integrals. Okay, first of all let us discuss about double integrals. Okay, here the double integrals are defined over some region denoted by capital R, or else denoted by domain capital D. That means there is one function. Let us take the function that is let f of x comma y be a function of two variables x and y. Okay, be a function of two variables, be a function of two variables x and y, two variables x and y. And let us take this function, it will be defined, comma, is defined over some region, is defined over the region or domain, over the region, or domain. Generally the regions are denoted by capital R, or a domain is denoted by capital D. Means if you're taking one subplane x comma y plane, or a two-dimensional plane, for example like this, x-axis and y-axis. Suppose the x-axis and y-axis. Here you can take some region, like this is a region we are taking as, this is a region, and the region is bounded by some closure curve. This is closure curve is denoted by capital C, and the region completely, this is called the region, and this region is bounded by closure curve C. Generally the region is denoted by, just I am making undo. Okay, this is a region capital R, or else you may call domain D. Okay, so this is a region bounded by closure curve C. Next, over this region, our function f of x comma y will be defined. Means every value of the function will be lies within the region R, and in this region the function f of x comma y will be defined, and that means is a continuous function. And how to evaluate the double integral, and how to define the double integrals over this region R. Generally the double integrals is denoted by two successive integrations. The two successive integrations are taken over the region R for the function f of x comma y into dr. Here only we are taking only differentiation with respect to R, because with respect to over the region R. Next, this is a general form of the double integral for the function f of x comma y, and this double integral is defined over the region R. Next, how to evaluate this double integral? The evaluation of the double integral process. Evaluation of double integrals. Evaluation of double integrals. There are two ways we can evaluate this double integral. That is, I will write as method 1. Method 1. Next, so here we can have two methods in method 1 and method 2. These two methods are how we are defining the region R. How we are defining the region R. This is only general region only. In particularly, if we are drawing the diagrams, then we will see what the region, how we will define the region R. So in method 1, let us take the region R. Let capital R be the region, comma, can be expressed as capital R equals to that is there are two functions, that is assume that f1 of x is less than or equals to y is less than or equals to f2 of x, and x is defined as between a is less than or equals to x less than or equals to b. like this. If you are defined the region capital R will be the region that can be expressed as like this. That means y will be the value. Y is the value that lies between two functions f1 of x and f2 of x. If the y lies between two functions f1 of x and f2 of x, and x lies between two constants small a and small b. If I draw the diagram for these two, how you will get C. For example, in the xy plane, x-axis and y-axis, x-axis and y-axis. Okay, let us take the curve that is f1 of x less than or equals to y, f1 of x less than or equals to y, and one more is y less than or equal to f2 of x. First of all, we will take the curve, that is, we will take the curve for first curve, that is, your y is less than, that is function f1 of x is less than or equals to y. So let us take this is as a function y equals to f1 of x first. f1 of x means let us take this a general curve. In general, let us take this is the curve y equals to f1 of x. And the same way second curve y less than or equal to f2 of x. What is the second curve equation? f2 of x. For example, you can take this f2 of x is one more curve y equals to f2 of x. So where is the values of y lies between the two curves? This is the equation of the this curve is f1 of x, and equation of the second curve is y equal to f2 of x. So all the y values are lies between these two curves, lower curve as well as upper curve. What is the lower curve equation? That is y equals to f1 of x, and what is the upper curve equation? Y equals to f2 of x. Right? So all the y values are lies within these two curves. These are the points, all the y values within the two curves, lower curve as well as upper curve. And next, x lies between two constants, x is equal to a and x is equal to b. For example, let us take here x is equals to a, and here x is equals to b. So by geometrical meaning of x equal to a means is a straight line. Is a straight line. That line passes through the point x is equals to a. This is a straight line. And x equal to b is also called is a straight line. The line passes through the point x is equals to b. Now tell me, where is the region completely? The region is bounded by lower curve as well as upper curve. Okay, upper curve, and the line x is equals to a. This is a line x is equal to a, and this is a line x is equals to b. Right? Okay, let us take different color pen, that is okay, some orange color pen. So now it becomes, this is the curve completely region bounded by lower curve and upper curve, right? And the first line equation is x is equal to a, and second line equation is x is equals to b. This is a geometrical meaning of the region. How we are expressed this. Capital R be the region, can be expressed as like this. Okay. This. Next, how to evaluate this double integral? So that here next I'm going to write. So here the board is over. Next I'm going to add a new board, board number 5, and here the color is taking as only white color. Board number 5 I'm taking white color board, and so next I am choosing the color is black color pen. Okay. So that generally the double integral is denoted by like this: double integral over R into f of x comma y into dr. Next, this is a general form of the double integral, and this double integral can be evaluated. First of all, we need to rewrite, because here two integrations are there and only one integration variable R is there, but two integrations we require two variables. That means first I will write first integral and the second integral. and the function is f of x comma y, and the function is f of x comma y. And go back to previous board. Board number 4 is a green color board. And first of all, here y is the variable that lies between two functions, f1 of x and f2 of x. So what are the y limits? Lower function and upper function. In the graph, what are the y limits? Lower curve to upper curve. So y limits are lower curve to upper curve. What is the lower curve equation? Y equals to f1 of x. What is the upper curve equation? Y equals to f2 of x. So in the integration, inner integral taking as function y equals to f1 of x, lower curve equation and upper curve equation. So y varies from lower curve to upper curve. These are the y limits. The same way x limits. So this region x varies from where to where? First line. This is what is the equation of this line? X is equals to a. And what is the equation of the second line? X is equals to b. So that x varies from where to where? From x is equal to a to x is equals to b. So what are the x limits? X is equals to a to x is equals to b. And next, this integral. Next, what are the inner integral limits? Y limits. So first of all, here the function should be integrated with respect to y and then integrating with respect to x. So first dy and then dx. Next, here the procedure how to evaluate this is like this. I will write first. Here comma the first the function f of x comma y, f of x comma y is integrated with respect to variable y within the limits. What are the limits of y? Okay, between the limits. Okay, what are the y limits? Y equals to f1 okay, f1 between the limits y equals to one minute. Sorry. Then limits y equals to between the limits y equal to f1 of x to second function is f2 of x, f2 of x, f2 of x. Okay, and then the result sorry, and then the result, 1 minute, between the limits y equal to f1 of x to f2 of x by keeping the variable x as temporarily constant, temporarily constant, and then the result is integrated, the result is integrated with respect to y, sorry, with respect to x between the limits, between the limits or the limits of x is equals to a and x is equals to b, x is equal to b. This is the first method procedure. Once again, let me discuss. Right? Here, this is the function. There are two variables, function of two variables x and y. So, if you are integrating with respect to y, integrate only y variables and then keep x as sometime constant. Right? So, only integrate y variables and keep x as constant between the limits. What are the y limits? Y equal to f1 of x to f2 of x. And then after integrating with respect to y and applying the limits, and all the y variables are replacing by function of x and function of y. So all the y variables are replacing by x variables. So after completion of the inner integral, the function completed this function becomes only the function of x variables. Only the function of x variables. So then the result is, what the result? Function complete after evaluation of this inner integral, you will get what? Only the function of x variables. And then the result is integrated with respect to x between the limits x is equal to a and x is equals to b. This is the method 1 procedure. Okay, let us have discuss a small example based on method 1. Okay, for that, let us take one example. Okay, let me have a red color pen because I'm writing an exam question. Example is evaluate the double integral from 0 to 4 and integral from 0 to x square and e to the power of y by x into dx into dy. Okay, next let me have a blue color pen. Solution. So what is the given double integral? Given double integral is this integral from 0 to 4 and integral from 0 to x square e to the power of y by x into dx into dy. And you should remember, first of all, you should forget about this order. This is by default in questions on in our examination. They will give by default orders dx into dy, and sometimes they will give original order. But the student only should identify what is the order. Is it dx into dy or dy into dx? Okay, so sometimes just forget about this order dx into dy. And how can you write this order? Okay, what is the first integration? Integration from 0 to 4. And the second integration is integration from 0 to x square. And you clearly can observe that in the second integration, the limits are in terms of x variables. Right? Limits are in terms of x variables. Just go back to our definition here. So here y is the limits, the function of what variables? X variables. Limits are in terms of x variables, then you can take as y limits. Once again, limits are in terms of x variables, then you can take as y limits. So that here we are taking these limits are 0 to x square. The limits are we are taking as y limits. So y limits are 0 to x square, and the remaining are x limits. And into e to the power of y by x into, now what is the order? The inner limits are, inner integration limits are y limits. So first of all we are taking as y. Okay, y. And our outer integral limits are x limits. So, and that we will take as into dx. This is the order what we are taking the double integration. This. Now first of all evaluate this inner integral. First of all evaluate this inner integral. What is the inner integral? Y equals to 0 to x square e to the power of y by x into dy. So in this function how many variables are there? Two variables are there, x and y, right? And here integration with respect to which variable? Y. So integrate only y variables, by keeping x as constant temporarily. By keeping x as constant temporarily. Once again I am repeating, whenever you are integrating with respect to y, integrate only y variable, and then x variables are keeping us constant temporarily. Okay, just make it neat. For that I am making undo all the things. This. So first of all here integrate with respect to y. Here already we know the formula of integration. Okay, what is integration of e to the power of x? Integration of e to the power of x is e to the power of x. And what is the integration of e to the power of a into x into dx? That equals to e to the power of ax by a. Integration of e power of ax into dx is equals to e power of ax by a. This is the function, because here integration with respect to x variable. In the function, what is the x coefficient here? A is constant. That constant comes under denominator. Right? These are the integration standard formulas. Remember these two. Once again I am repeating. Here integration is with respect to x variable, and here x coefficient is a and is constant. After integration, this a comes under denominator. Okay, let's come back to our problem. And here integration with respect to what? Y variable. So what is the integration of exponential? What is integration of exponential? Integration of exponential is again exponential. So x is equals to 0 to 4. This is writing as this. And inner integral. Integration of exponential is again exponential. But okay, but here integration with respect to which variable? Y variable. So what is the y coefficient here in the function? Y coefficient becomes 1 by x. So that 1 by x comes under denominator. So this integration is over. So limits y equals to 0 to x square into dx. So inner integral is completed. Next I am going to apply the upper limit minus lower limit. Limits are applying in place of y variables. So in the next, first of all I will rewrite this integration properly. Integration x is equals to 0 to 4. Okay, here by 1 by x means that comes into numerator, and e to the power of y by x into the limits are y equals to 0 to x square. Y equals to 0 to x square into dx. Okay, next apply the limits. This equals to integration x is equals to 0 to 4 into x into. So what is the upper limit? X square. That put in place of y variable. So e to the power of x square by x minus lower limit is e to the power of 0 by x. into dx. Next, this is equals to, here x square by x cancel, remaining is only e to the power of x. X is equals to 0 to 4, x equals 0 to 4 into x into a to the power of x minus, here a power 0 by something. 0 by something is always 0, right? 0 by something is always 0. So a power 0 by something is 0. A power 0 means 1. 1 into dx. So here, first of all, your integration is completed. The integration of a power of y by x is a to the power of y by x by 1 by x. And what are the limits of y? Y equals 0 to x square, right? Integration is over. Next, in the next step, rewriting this, x into e to the power of y by x, limits are y equals 0 to x square, and applying the limits in place of y, right? In place of y. So, the next step. So, y replacing by x square, right? X square by x minus a power of 0 by x. Next, x square and by x cancel here. Remaining is only e to the power of x minus a power 0 means 1, right? Okay. Next, after integrating and applying the limits, finally what you are getting? This. This is our result. In this result, in this result, how many variables are there? Only single variable. What is single variable? X, right? Is a variable function here, only single variable. That's the reason. So integrate with respect to y and applying the y limits. Finally, you will get the result is in terms of x variables. In terms of x variables. Next, integration with respect to which variable? X variable. Now we can integrate this by using integration standard formulas. Next, now integrating this equals to, okay, I'm adding one more board. This board color I will take as black color board. Okay, so for the black color board, it is better to take white color pen. Okay, continuation of previous board, continuation of this. Okay, okay. First of all, rewriting this. This is equals to integration 0 to 4 into x into e to the power of x minus x into dx. There you may integrate directly or write separate and then integrate. Integration 0 to 4 into integration 0 to 4 into x into e to the power of x into dx minus integration 0 to 4 into x into dx. Integrations are writing separately. Next, evaluate the first integral. This integral can be evaluated by using bypass formula, integration bypass formula. So what is integration bypass formula? Integration of u into v into dx equals to, first u integration of v minus integration of differentiation of u into integration of v, whole integration. This is integration bypass formula. Right. So applying this integration bypass formula, you can evaluate this integral. Here I will write, here I am going to write. Okay, first here u is x into integration of e to the power of x into dx minus, okay, integration v is over, minus integration of differentiation of u. What is the u value? X, and integration of v. Integration of v means integration of e power of x into dx into dx, right? Add minus this function, right? Minus this one. For integration of x here, x square by 2, or the limits of x here 0 to 4. Okay, here first of all let us complete the integration and then apply the limits. Okay, next. Okay, right. This is equal next x into integration e power of x means e to the power of x minus integration of, or the differentiation of x here 1, right? Integration 1 into integration of e power of x is e to the power of x into dx minus, okay, here you can apply the limits. Okay, what is the upper limit? 4 whole square by 2 minus 0 square by 2. Right. Next here x into e to the power of x minus integration of 1 into e power of x, e power of x. What is integration e power of x? E to the power of x. Integration is over. Next, what are the limits are here? 0 to 4. 0 to 4 minus, yeah, 4 square means 16 by 2. 0 by 2 means 0. Next, okay, this is equals to, apply the upper limit. 4 into e to the power of 4 minus e power of 4. Upper limit is over, minus lower limit. 0 into e power 0 means 0 minus e power 0 means 1 minus 8. Next, it is writing clearly. It is writing clearly. 4 a power 4. 4 into a power 4 minus a power 4. That is 3 a power 4. Here minus of minus 1 plus 1 minus 8. So final answer is 3 into e to the power of 4 minus 7. This is the final answer. Right? Okay. Let me go for discuss one more example. That is adding new board for that. Okay. For this here I am taking the green color board. Next, for green color board, white color pen is suitable. Next, here I am going to one more example. That is a graphical interpretation problem. Okay, evaluate. Double integral over the region R into y into dx into dy. I already told you this is by default. You no need to worry about that. We only take the order. Is it dx into dy, or is it dx into dy, or dy into dx? That is student only need to identify the order. Okay, so you no need to worry about the given order in the problem. Comma, where capital R is the region, capital R is the region bounded by two parabolas, two parabolas is y square equals to 4 into x, and one more parabola is x square equals to 4 into y. X square equal 4 into. This is our problem. Okay. So evaluate double integral over r into y into dx into dy. Okay. This is a double integral. Here r is what? R is the region. R is the region bounded by two parabolas y square equal to 4x and x square equals to 4y. Okay, let us discuss about this. Okay, solution. Okay, for this I will take a different color pen. Color solution. I can indicate solution. First of all, discuss about the region. If you are finding the region perfectly, then the problem will be completed. First, let us concentrate on the region R. So here R is the region, right? R is the region bounded by two parabolas y square equal 4x and x square equal 4y. Here the limits are not given for these two double integrals. We need to find the limits. That is possible only by drawing the diagram. Okay. Okay, let us take. So given capital R be the region, capital R be the given be the region, comma, bounded by the two parabolas, bounded by the two parabolas, okay, two parabolas. One is y square equals to 4x and one more is x square equals to 4y. Okay, let us draw the diagram and find the region where it is from the diagram. Okay, for that I will take the two-dimensional plane. In the two-dimensional plane, one line is x-axis and one more line is y-axis. So already we know the shape of this diagram, the parabola y square equal to 4x. The shape of this parabola is symmetric about x-axis because this is the even power for y. This is the even power of y, so that the parabola shape is symmetric about x-axis. So that the shape is, you can take like this. This is the shape. And one more function is this. X square equals to 4y is also a parabola. But this is symmetric about y-axis because this is an even power for x. So this is symmetric about y-axis. Okay, let us, if we are drawing the diagram for this, we'll get like this. Like this, right? So there are two curves. These two curves are bounded subregion. Where is the region? Where is the region? This is our region, capital R. This is a complete region is bounded by the two parabolas y equal to x square and x square equal to, sorry, y square equal to 4x and one more is x square equals to 4y. Okay, this is a region R, right? Okay, making undo the shaded region. So this is a region R. This region R is bounded by two parabolas. One is this parabola. The equation of this parabola is for that y square equals to 4x, and one more parabola is this one. Okay, this one. Okay, this one, this. Okay, okay, this is a region R. Next, so this is a region R. For this region R, what are the lower curve for this region R? What are the lower boundary for this region R? What are the low? What is the 4x? And what is the upper curve equation? This parabola equation is x square equals to 4y. Right? So upper curve. This is the upper curve. Okay, let me choose different color pen. Black color. This is the upper curve for the region, right? What is the upper curve equation? Y square equal 4x. So this is a y square equal 4x means y equals to how much? 2 root x. And this is a lower curve equation, right? This is a lower curve. What is the lower curve equation? X square equal 4y. Then y equals to how much? Y equals to x square by 4. So go back to board number 4, please. Here in the method what? R is what? R be the region. Can be expressed as R equals to f1 of x less than or equal to y less than or equals to f2 of x. And here f1 of x means the diagram is lower curve, right? Y equal to f1 of x. And f2 of x means in the diagram is upper curve. This. So one is lower curve and one more is upper curve. So in our board number 7, so what is the lower curve equation? Y equals to x square by 4, and upper curve equation is y equals to 2 root x, right? And so limits y varies from lower curve to upper curve. Y varies from lower curve to upper curve, right? And tell me x varies from where to where. And here x varies from, to get the x values, we need to take the projection of the region on x-axis. So completely this is a region, right? This region is varies from here to here. If you're taking the projection of this region on x-axis, you will get the shadow from here to here, right? This. So complete this region is varies on x-axis from here to here, right? Here the point is already, if you know, this is origin. The point is called 0, 0. And here what is the point? That very point. To get this point, first of all we need to find this point. This point is called intersecting point of the two parabolas. To get the intersecting point of these two parabolas, we need to solve these two. Okay, let us solve these two equations. What is the first curve equation? There is y square equal to 4x is a one curve equation, first curve, and the second curve equation is x square equals to 4y is a one more equation. Okay, solving these two equations. Okay. So from second curve, from 2, I will take y value. From 2, y equals what? X square by 4. Y equal to x square by 4. Y equal to x square by 4, substitute in 1. And put, this is not rough work, fair work only. And put in 1. Okay, what is the one equation? Y square equal 4x. So y equals how much? X square by 4. So x square by 4, x square by 4 whole square equals to 4 into x. This is equals to, okay, x square by 4 whole square. X square whole square means x power 4 by 4 square means 16 equals to 4 into x. Next, this is equals to x power 4 equals to 64 into x. Next, this is equals to x power 4 minus 64 into x equals to 0. Next, from these two, x taking common, you will get x cube minus 64 equals to 0. Next here, x into x cube minus 64, something into something equals to 0. Okay, something into something equals to 0. Then either x is equals to 0, or x cube minus 64 equals to 0. X cube minus 64 equals to 0. So here x cube minus 64, okay, x equals 0 is okay, and x cube minus 64 means x cube is equals to, writing as 4 cube, and both side cube cancel, remaining is x is equals to 4. So what are the x values? X is equals to 0 is 1 point, and x is equal to 4 is 1 more point. So here in our diagram, here x is equals to 0 comma 0, right? So in one of the equation, you can put, if x is equals to 0, then what the y value? X is equals to 0. That implies y equals to 0. And if x is equals to 4, then what the y value? Also 4. So what are the 2 points, 2 intersecting points of these two curves? X comma y equals to, one is intersecting point is 0 comma 0, and one more intersecting point is 4 comma 4. See in the diagram, those two curves are intersecting. One is at 0 comma 0, and one more is at 4 comma 4. Next, the projection of this point on x-axis, is 4 comma 0, because on x-axis y was 0. So here what are the x limits? 0 to 4. These are the x limits, right? Okay, so here we know the x limits and y limits. Once again, what are the y limits? Y limits are lower curve to upper curve. What is the lower curve equation? Y equals to x square by 4. And what is the upper curve equation? Y equal to 2 root x. So y limits are lower curve to upper curve. And what are the x limits? 0 to 4. Right? Okay. So let us take the problem next. This is a completely fair one, not proper. By looking this video once again, you can rewrite notes clear. Okay. Next, I am going to start this solution. Okay, our class is going to extend. Class is going to end next 5 minutes. Okay, just I'm extending the class only 5 minutes. Now the class timings is still there are 10 minutes. Within 10 minutes, we need to complete this problem. Okay. So solution is is already started at solution. Okay. So here I'm writing. So given R with a region bounded by the two parabolas y square equal 4x and x square equal 4y. Now this region rewriting as therefore over this region over the region R over the region capital R. Tell me limits of y and x. Y varies. Y varies from y equals to lower curve or the lower curve equation x square by 4. Y varies from x square by 4 to upper curve equation or the upper curve equation y equals to 2 into root x. The same way x varies on x-axis. X varies from x is equals to 0 to x is equals to 4. Right? From the diagram. Here x is equals to 0 and here x is equals to 4. Or else you may take on x-axis also, no problem. X is equal to 4. Right? Okay. So no x limits and y limits. So therefore our integral is therefore double integral over r into what the integral or the integral this one double integral over r into y into dx into dy. Okay, so this your order is dx into dy. This is by default order, you don't need to consider. So by watching this, by identifying, by looking, by observing the diagram, next we are going to write the limits in this integrations. So double integral over r into y into dx into dy. This is by default order. Okay. Next, first write the constant limits. The constant limits are x is equals to 0 to 4. Next, and inner integral. Y limits are y equals to lower curve limits x square by 4 and upper curve is 2 root x into y into dy into dx. So what is the order of integration here? Dy into dx. That is the method 1 process. Whiteboard number 4. This is white number 4. So how we are writing in this integral limits? Okay, once again. Okay, board number 5. So the integration order is dy and dx, right? So here also we are writing dy into dx. Next, here only integration with respect to y, only y variable is there, so you can integrate y. So what integration of y is x is equals to 0 to 4 and integration of y is y square by 2. Y square by 2. Okay, integration of y is over and y limits y equals to x square by 4 and 2 root x into dx. Next, applying the limits. We're just extending again 5 minutes. Okay. Next, adding one more board. This time taking black color board. Okay. This is equals to integration from x is equals to 0 to 4 and go back. So y square by 2. By 2 writing outside and upper limit is 2 root x. So replace put in place of 5. So by 2 writing outside, 1 by 2 writing outside and y square. So y value is 2 root x, this is upper limit, whole square minus lower limit. For the lower limit, x square by 4, right? Okay, x square by 4 whole square, x square by 4 whole square into dx. Next, simplify all this. 1 by 2 into integration from x is equals to 0 to 4, 0 to 4. Okay, 2 root x whole square means 4 into x minus x square by 4 whole square, that is x power 4 by 16 into dx equals to 1 by 2 into, okay, now integrate in all only x variables. Next, integrate with respect to x. 4 into, what is integration of x? X square by 2 minus 1 by 16 into, okay, what is integration of x power 4? X power 5 by 5. Okay, integration is over. Next, apply the limits. 0 to 4. Next, 1 by 2 into, first of all, apply the upper limit. 4, 2 into 2, cancel. 2 into, what is the upper limit? 4. 4 whole square minus 1 by 16 into 5, that is 1 by 18, and 4 power 5, upper limit is over, and minus lower limit, x equals 0 means 0 minus 0. Next, equals to 1 by 2 into, and 2 into 4 square means 16, 16 into 2, 32, minus 4 power 4, 4 power 4 means, that is 4 into 4 into 4 into 4 into 4, 4 into 4, 16, 4 into 4, 16 into 4. Next, 16 into 16, 256 into 4. Next, this is equals to 24, sorry, okay, 6 into, sorry, 4 into 6, 24, 2 writing outside, 4 into 5, 20 into 2, 22, next, 4 into 2, 8 plus 2, 10, 1024, 1024 by 80. Next, on simplifying this, equals to 1 by 2 into 32 minus, okay, denominator 16 5s and this is 16 64s. Here we will get 64 by 5, and finally simplifying this value will get 48 by 5 will be the answer. This is the result. Okay, in the tomorrow's class we'll discuss how to evaluate. Okay, we'll discuss about the differential equation. Differential equations. Okay, in the next 5 minutes our session will be completed. Differential equations. What type of differential equation? Higher order differential equations. Higher order differential equations, and we are going to discuss finding complementary functions. Complementary functions, that is called, denoted by CF or YC. and signing off. Thank. Okay, one thing. The regular classes will start on regular classes will start on 20th. Okay, 20th April 2015 at 6:30 to 7:30. Okay. You can go and register on my website www.bizmathIQ.com. Thank you. Okay. Once again, the website address is www.bizmathIQ.com. Change the learning style. And the important thing is this today's session recording will be available after 4 hours. Again, you can click on the same link. The session recording will be available to you always. Whenever you want, you can recap, you can view, you can visit your recording sessions. The recording sessions are very useful whenever you are on the traveling by bus in college in your college bus. Just you can view just you can revise the class that is over to recap of your previous classes. Right. Signing off. Bye.